Good afternoon. Good afternoon. This is Andy Schweitzer, and looking at doing a quick little example of a friction slash force example. Let's do number 3. Um, let's take a box and make sure my pen works. Okay, we'll take a box here and say the box is, again, we'll just do the standard 5 kilograms. And rather than push the box, or we're going to pull the box with a rope, and let's go with a angle here that is about 30 degrees. Okay, so box is sitting on some surface. It's kind of a rough surface, so it's got a coefficient of friction equaling, let's go with 0.5. And all right, so our overall question here is, what is the acceleration of the box? I'm going to put a 50 Newton force on this box. Okay, first things first, let's start drawing out all of our forces. So step 1 is the label forces. I have the force of gravity going down. I'm going this way, so this is going to be the force in the x direction. I'll label that in a second here, as far as the component force. And then this is going to be the force of friction. We have the force normal, right? So let's just go ahead and put these on here. Force of friction equals, I got the force normal. This component here, because I'm not pulling in the same direction as the plane, some of it is going up and some of it is going down. So I'm going to take my little triangle here and let's break this into the components of the angle 30 degrees. This is 50 newtons. I'm looking to break this into a force in the y direction and a force in the x direction. All right, this is going to take a little bit of trigonometry, and of course the trig shortcut is SOHCAHTOA, and this is going to allow us to just remember how the sines and cosines relate. For f of y, it's the sine of the angle equals the opposite over the hypotenuse, and this is going to be equal to sine of 30 degrees equals the force in the y direction, and then this is the 50 newtons, which is the hypotenuse. So force y equals sine of 30 degrees times 50 newtons equals force in the y direction. The cosine of the angle is equal to the adjacent, which is that force of x in the x direction, or the hypotenuse. Cosine of 30 degrees equal to force x over the 50 newtons, and I'll put this here. Force in the x direction equals the cosine of the 30 degrees times the 50 newtons equals force x. All right, so I have all my forces on here labeled. I did not put my force y on here. Force y, and that is going up. All right, so the second force here, second thing I'm going to do here is to break it into x and y components and look at how the forces resolve in each direction. So in my x, let's go to the y component first, because the box is not moving up or down. It's static in the y direction. So all my up arrows are balancing my down arrow. If they didn't, the thing would be leaving the ground. So force of gravity equals the force normal plus the force in the y component. Alright, so in this case, the force of gravity equals mass times acceleration, and for this guy that would be 40, that'd be 50 newtons times 9.8, which is 49 newtons. Alright, but if I want to solve this thing for the force normal, the force normal is equal to the force of gravity minus my force in the y direction equals my force normal. So I just basically isolate this guy, solve for Fn. So my y component is balanced. I'll just rewrite that. Force normal equals force of gravity minus force y. So let's just rearrange that. My x component, now I don't know that I'm static. I'm assuming that maybe my force is allowing me to move to the right. So the sum of all of my forces in the x component is equal to the force provided by force of x minus my force of friction. Force of friction is the coefficient of friction times the force normal. And in this case, I would like to find what is my net force. That's ultimately what I want to find. Well, not ultimately, eventually I would like to find that. Alright, so let's start plugging some values in here. The force normal is one thing I want to find, and I can put this so I'm not so crammed. I'm just going to have to add a page for calculations. Alright, so I want to find my force normal. My force normal is the force of gravity times, oops, let's see, will this work? Okay, just slide it over here. Nope, let's just copy it. Alright, probably rewrote it in this one time. Okay, we'll copy this thing and put it right here. Alright, let's write it out. Force normal is equal to the force of gravity minus my force in the y direction. So all I'm doing is isolating, in this case, what my force normal is. This is going down. These two are both going up. So in this case, my force normal has a little bit less because some of it is being lifted up here. My force of y is sine of 300. Oh, I do. Oh, very good. We'll just do it this way then. My force normal, all right, is going to be here. It's going to be force of gravity, and then minus my force of y. So force normal equals the force of gravity, which is 49 newtons, and then I need to figure out my force of y. Okay, now my force of y is right here. The sine of 30 times 50 equals, okay, the sine of 30 times 50 equals 25 newtons. I'm just going to do the other one right away. The cosine of 30 times 50 equals 43.3. Okay, so equals 43.3 newtons. Alright, so in this case, my force of normal force is force of gravity minus the force of y. Force of y is 25, so minus 25 newtons. And this will give me, what, 24 newtons? 24 newtons is my force normal. And then I have this guy here waiting. What else do we have? So now I want to figure out eventually my x component here. My x component is going to be the force of friction, force of x component, which is this guy, 43.3 minus the force of friction. Now the force of friction is, this is the reason why I needed the 24. The force of friction is the coefficient of friction times the force normal. So this is equal to 0.5 is the given coefficient of friction, which was given over here. And now the force normal is 24, will give me my force of friction. Half of 24 is just going to be 12 newtons. And 43.3 minus the 12 newtons, so I have a forward force here of 43.3 newtons. I have a frictive force of 12 newtons, okay, and gives me a net force 12 newtons, 43.3 minus the 12 gives me 31.3 newtons. And this is the net sum force and is going in to the right, 31.3 newtons. Now that didn't answer our question yet, but just recap here. I have a force normal of 24 newtons, so I'll label this 24 newtons. Okay, the force of gravity is 49 newtons, so the force in the y direction is 25 newtons. So notice how these add up to this, they balance. This is 43 newtons, this is 12 newtons, so I have a net force in this direction of 31.3 newtons. So this box will be moving to the right. How fast, or what will be the acceleration of the box? Well, one more last calculation. The force is 31.3 newtons, mass 5 kilograms. What is the acceleration? 31 divided by 5, the acceleration is going to equal 6.26 meters per second squared. And so a couple things here. Again, same process, always the same. We label our forces, try and get a picture that's accurately describing everything that's going on in this thing. It looks a pretty neat picture here. And then at that point, break into your components. What is going on in the y direction? What's going on in the x direction? Is it moving? What's the component force? What's the sum of all the forces? In this case, of course, the sum of the y, the sum is all 0. We have a net force in the x direction. Thank you very much.